So if we want to do stoichiometry with electrolytic processes or electrolysis, we would need to be aware of current flow. So stoichiometry calculations with electrolysis. So we're going to set up an electrolytic process and let the current flow for a certain amount of time, and then do some calculating about how much product can we make, how many grams of this or moles of that can be made. And to do that, we have to know something about electric current. Electric current is measured in amps, or amperes, technically, but it gets shortened to amps. And even further shortened to just capital A for amps. 1 amp is equal to 1 coulomb per second. Coulomb of charge, remember Faraday's constant, 96,500 coulombs in 1 mole of electrons. An amp is 1 coulomb of charge passing a gateway in 1 second. So this can be rearranged that 1 coulomb is equal to 1 amp second. Moving the second over to the other side, going up into the numerator. This is a key relationship that we have to keep in mind when we want to do calculations with electrolysis. So working toward that here, if a 2 amp current flows for 30 seconds, how much charge went through? 2 amp current flows for 30 seconds. How much charge was passed during that 30 seconds? 2 amps times 30 seconds is 60 coulombs of charge. Remember, 1 amp is 1 coulomb per second. So 2 amps is 2 coulombs per second. Times 30 seconds, we get coulombs out of that. Okay? This kind of calculating allows us to do stoichiometry with electrolytic processes. If we know how long a particular current has passed, there's a relationship between the current and time and the moles. Remember, coulombs can be related to moles of stuff because there's 96,500 coulombs in a mole of electrons. So that's our step into the stoichiometry part of this. All right, so we're going to now look at one that's a little bit more complex, but not too bad. How many grams of aluminum are deposited by electrodeposition That's a fancy term for an electrolytic cell. So electrodepositing aluminum, how many grams of aluminum are deposited by electrodeposition? At the cathode, if 3.65 amps of current flows for 40 minutes. So aluminum is being deposited, Al3 plus, aqueous, or from a fused solution. We'll just leave the state out of it. State doesn't really matter. Al3 plus 3 electrons, making Al as a solid. We had to know how many electrons are being transferred there. That's going to feed into our current and charge. We also need to know something about time, but we got seconds to deal with for our amps, so we're going to need the minutes into seconds. I'm going to do this all as one set of conversions. So I'm going to start with the amps, 3.65 amps. Amp seconds is coulombs from before, right? Amps times seconds gives us coulombs of charge. Coulombs is where we need to go to get into the stoichiometry part, because this relates to moles. So 2 amps up there. Now we got 3.65 in this problem. 3.65 amps flowed for 40 minutes. We got to get the minutes into seconds because it's a second relationship on the coulombs. So 40 minutes. Now we have amp minutes. So we want 1 minute is 60 seconds. That gets us into seconds. Our minutes cancel. Amp seconds, those are coulombs. Now this conversion factor right here illustrates that. 1 coulomb is 1 amp second. Just like we had a bit ago. 1 coulomb is 1 amp second. That's a key to stoichiometry. Amps cancel and seconds cancel. I know how many coulombs of charge I have. Now I can use Faraday's constant to get into moles. 1 mole of electrons is 96500 coulombs of charge. Now my coulombs go away. I know how many moles of electrons I need to do this conversion. Now from the equation we wrote up here, it's a 3 electron reduction. So 1 mole of Al is 3 moles of electrons. Moles of electrons cancel. 1 mole of aluminum is 27 grams. All right, before we do the calculating, we made it to the end. We know how many grams of aluminum. Let's go through and look at what we did on the setup. I don't want to lose anybody. In order to start this out, we multiply our amps times our time in seconds. So 3.65 amps times 40 minutes converted to seconds. So this part right here is amp seconds. Then we converted it to coulombs. We need the coulombs because that gets us into stoichiometry and moles of things. 1 coulomb is 1 amp second. That's where we canceled out our amp seconds over there. Once we know coulombs, we use Faraday's constant to get into moles of electrons. 96,500 coulombs of charge per mole of electrons. 3 moles of electrons were required for every mole of aluminum that gets produced. And every mole of aluminum is 27 grams. So now we're ready to calculate. 3.65 times 40 times 60 divided by 96500 divided by 3 times 27. I get 0.816 grams. Which is not very much aluminum. It's not a very big current. It didn't run for very long. When they do this on an industrial scale, which is how they make aluminum, how they purify aluminum, they run huge power lines into these factories because it takes a lot of juice, a lot of electrical current to produce aluminum. The last time I read, I think it was, the numbers were from back in the 90s, about 1/3 of the electricity in the United States went into this reaction to generate aluminum because we have such a big demand for it. And it requires a lot of energy because it's 3 moles of electrons per mole of aluminum. So this is the kind of calculating that we do with electrolytic processes. We need to keep our relationships in mind. You'll have them printed out on your sheets come exam time, I hope. 1 coulomb is 1 amp second. That was the key here that got us from time and current into moles, where we can do stoichiometry. All right, we'll come back with one more example before we finish up, okay?